When we look at this function, it's not immediately obvious that we can apply the rule of the integration by parts to this function, because we have a log of x. We have the integral of log of x from 5 to 4. But if you just realize that you can introduce a term here, so we go from 5 to 4, we introduce x to the power of 0, which is equal to 1, times the log of x dx. We can now look at this as a problem where we are integrating, we're applying our integration by parts, where one term is the log of x and the other term is x to the power of n, where n is equal to 0 in this case. So if we go ahead and follow our procedure, and we come to our rules, it says if one of the factors is a log function. Now the example here is a natural log, whereas here we have the standard log to the base 10. So it doesn't matter, the same rule applies for each one. So what we do is we set that equal to u. Now I'm going to solve it just as an indefinite integral to begin with, and then I'll apply the definite integrals at the end. So if u is equal to the log of x, that means dv is everything else. So it's x to the power of 0 dx, which is basically 1 times dx. Any number to the power of 0 is 1. So just to remind, what we've had to do there is introduce x to the power of 0 to let us use this rule. If I then differentiate this, du dx is equal to 1 over x, that implies that du is equal to dx over x. On this side, if we integrate both sides, the integral of dv is equal to the integral of dx, so v is equal to x. We plug the values into our integration rule, our integration by parts rule. So u is log of x, dv is dx. So we have what we started with, and that is equal to u times v. So it's the log of x times x minus the integral of x, and over here we have dx over x. So that's my u, that's my v, and that's my du. And here we have u dv. So you can see we have all the values that are correctly plugged into that formula, and that gives me x times the log of x minus, and you can see here that that x cancels with that x. So what we end up with here is the integral of dx. So that gives us x times the log of x minus x, which is x times the log of x minus 1, plus a constant of integration. But of course we're going to do this as a definite integral. So if I just scroll down a little bit, our integral from 5 to 4 of the log of x dx is x times the log of x minus 1, and we're going from 5 to 4. 5 down to 4. So if we look at this example, I'll spread it out over here. That gives us 5 times the log of 5 minus 1. And this is minus, and then we can put the lower limit in, 4 times the log of 4 minus 1. And this basically gives us, so if we multiply this out, 5 times the log of 5 minus 5, and we multiply this side, it's minus 4 times the log of 4, and we have a minus times a minus, so we get plus 4. So what we end up here with is 5 times the log of 5 minus 4 times the log of 4 minus 1, because minus 5 plus 4 is minus 1. So that is the correct solution. You could evaluate these if you want, or you can leave it like this.